In this video, I'm going to spend more time with these CST questions because some of this stuff is new to you and some of it is review, and so we'll just kind of take it as we go. We'll start with question number, this is question 59, and because this is question 59, you need to disregard the number in the top left. At any rate, question number 59, this specific heat. The first thing you want to do with this is write it out. Write it out in terms that are familiar to you. And that is exactly what this guy should be. So once you have the stuff that was up here in the question, see, from here to here, I am rewriting that as this guy right here. So once you've done that, the other thing you need to look at is, what are they asking you to find? It says how much heat. So joules becomes the find, and because joules is the find, it has to be on top in that first fraction. Once you have that, the rest is easy sailing. So when you go back to construct the rest of this problem to get to the answer, you wind up with joules on top, and when the grams and the degrees centigrade cancel out with grams and degrees centigrade, you leave joules by itself on the top. So why do I have 30 grams on the top? Obviously to cancel with that grams, and that comes from this. It's funny, you know, when you look at this, you see the word gram, but you're used to seeing it like this. And so that's throwing you a little bit with this guy. Also, this guy and this guy being on different lines is something that can throw you. And the grams degrees centigrade, you're more used to seeing like this, and joules you're more used to seeing as just a plain old capital J. By the way, another reason you know that this has got to be the find is because every one of these answers has joules. So when you go through, the 30 grams becomes very simple. When we change it from 30-gram, we just have this 30G. And when we subtract the 20 from the 60, that's where we get the 40 from, because that is a temperature change. And that's what we have in specific heat, is temperature changes. And so by working that in this manner, you are able to see why we get the answer that we get. So I hope you find this very helpful. Okay, let's look at question 60. Remember, it's not 12, it's actually 60. So the equal volumes of hydrochloric acid and sodium hydroxide. That actually works out to something like this. So we see that neutralization takes a hydrogen ion here and a hydroxide ion here, and we make HOH, which is the same as H2O. This is neutralization. It is only neutralization, though, if we have the same amount of both hydrogen and hydroxide. Now let's look back at the problem. It says here we have equal volumes. That's your key. That's why it's going to wind up nearly basic, as I say in my short explanation there. So let's look at this in more detail. We've got a 1 molar hydrochloric acid solution. If I take 1 mole of these guys, I'll put in 1 liter of this, and to get 1 mole of these guys, the hydroxide ions, I need 1 liter of this. Why? Well, let's see. So, because both of these guys are strong, see, the hydrochloric acid is a strong acid. The sodium hydroxide is a strong base. Why is he a strong base? Because he's a metal with hydroxide. That's the definition of a strong base. And hydrochloric acid is one of our strong acids that we memorized. So because they're both strong, they ionize 100%, and instead of having this stuff in the water, we actually have a mole of hydrogen ions and a mole of chloride ions. Now I'm using hydrogen ions instead of the hydronium ion so that it's a little easier to see the one-to-one ratio of this guy to this guy. At any rate, so that's the acid, and of course the base is a strong base because it's a metal with hydroxide ions, and so we also get 1 mole of hydroxide. Equal numbers of hydrogen and hydroxide, and we've got it made. We have ourselves complete neutralization, or at least very close to complete neutralization. So here's the answer. Obviously this is D, nearly neutral, and now we have completed questions 60 and 59. 59 was here, and this guy is 59, and this guy is 60. Now we're going to go to the beginning of this file. And so this is question 61. Just like my demonstration in class today, with the nitric acid, a strong acid, and acetic acid, which is a weak acid. Okay, both conducted electricity because they ionized. And we saw that because the light went on. See, this is just a diagram of what I did in class with the light bulb conductivity tester. Well, sucrose is the only guy that does not form ions. Ammonium sulfate is an ionic solution, and hydrochloric acid is ionic, and sodium nitrate is ionic. So I thought I'd write the formulas for you down there, right next to each. And now let's look at what they actually ionize to. And there you have it. So I hope that helps you to see what was actually going on at the molecular level. Here we go with number 2, which the following is an observable property of many acids. Now what I wanted to do was show you here, and let's make this a little bit bigger so you can see it more easily. Here's your reasons, and also some new stuff that maybe we didn't cover very well. But letter A, where they become slippery when reacting with water. Okay, what we're talking about as being slippery when it reacts with water is bases. Okay, salts are produced when an acid is mixed with a base. Okay, they produce acid-base is neutralization. Mixing equal amounts of an acid and a base gives you neutralization. And so can't be letter B. And then in letter C, an acid mixed with a base will actually neutralize the solution. That's what C was all about. Salts are produced by a neutralization reaction. But then we see in letter D, this is actually a property of most acids when reacting with metals, which is why it is the correct answer. And what is that? It releases hydrogen gas. Okay, so now we've done 61 and 62. Let's go to 63. And what are we doing here? Notice that the copper hydroxide, notice that this guy is a base, copper and hydroxide ions, a metal with a nonmetal. However, this doesn't ionize real easily. That's why it forms a solid. So just a little bit of this will dissolve in the water. Okay, so most of it will settle out. However, when we force the issue by putting in nitric acid, the nitric acid will make this more soluble, and that is why this nitric acid here is reacting with the base, which will ionize it and cause it to be water. Water and the copper nitrate. Okay, we'll get more copper nitrate. So, at any rate, that's why this guy works, and that's why your answer on this one is letter B. Now, going to 64, our last one. The easily releasing the same is the same as ionizing easily. Okay, easily releasing is what they said in your answer, which is letter C. Let's look at that. See here, we got the words easily releases Okay, it easily releases what? The hydroxide ion. And that's what this metal is mixed with, potassium and hydroxide. So it's a strong base. And because it's a strong base, it ionizes easily, which is why it releases, which is another way of describing, it releases the hydroxide easily. And that's it, folks. Hope this helps.
Please